Hello guys, and welcome to this lesson, which is going to be inequalities in one triangle. Now we are actually combining two sections from the book in this PowerPoint. It's going to be sections 5.3 and 5.4. So if you get a little confused, that's where we are in the book. Otherwise, let's go ahead and get started. Now when we're talking about inequalities in one triangle, let's define exactly what an inequality means. What are we talking about here? And what we're going with is if we have a situation of A is equal to B plus C, then what our inequality is that A is greater than the individual pieces. Okay, so if I have the situation of 5 is equal to 2 plus 3, then 5 is greater than 2 and 5 is greater than 3. All right, if I had the situation of, let's go with 6 is equal to 4 plus 2. All right, then 6 is greater than 4, and 6 is greater than 2. Which makes sense, but we're going to be using that a lot in this PowerPoint, clearly. Now, let's talk about a few more properties of inequalities. First off, you got the comparison. So if A is less than B, A is equal to B, or A is greater than B. So we need to be able to say all of those words and be comfortable with what that knowledge means. Now, the transitive property of equality states that if A is less than B and B is less than C, then A is going to be less than C. Okay, so if A is less than something and that other thing is less than something else, then A is also less than that. Okay, let's plug in some numbers. So if A is, let's say, 4 is less than 10, okay, that's obvious, and 10 is less than 20, again, obvious, then it's the transitive property states that 4 is also less than 20. And it goes the other way around. So if we have the greater than, if A is greater than, same exact logic, just the symbol flips. We've gone over this. We've talked about how math is a giant game of Simon Says. You need to be told exactly what you can do. So this is just the math powers telling you that you can do this. Okay, so 4, or 20, I guess, is greater than 4. Now, the addition property of equality, if A is greater than B, and I add the same thing to both sides of the inequality, well, A is still going to be greater than B. Okay, so if I have 4 is greater than 1, and I add 3 to both sides, all right, well, 7 is still greater than 4. Okay, subtraction is the same thing. If I have A is greater than B and I subtract the same thing from both sides, it's still going to be greater than. So if 4 is greater than 1, all right, and I subtract 1 from both sides, well, 3 is still going to be greater than 0. Okay, so all of these rules are probably rules that make a lot of sense. They do make a lot of sense, but we just need to be told we can do it. So when we go to the problems, we can go forth with confidence. And here's the problem. Now, inequalities can apply to the measures of triangles as well and those segments. Anybody remembers the exterior angle theorem? The exterior angle theorem stated that the measure of angle 1 was equal to the measure of angle 2 plus the measure of angle 3. So the measure of the exterior angle was equal to the sum of the two remote interior angles. But think back to the last slide when we talked about the definition of an inequality, and you get where we're going with the exterior angle inequality theorem. What this one states is that the measure of angle 1 is greater than the measure of angle 2. Okay, the measure of angle 1 is also greater than the measure of angle 3. Okay, this is back to what we were saying in the last slide about A plus B, A being equal to B plus C, and A is greater than B, and A is greater than C. Same exact logic, only we're building from the exterior angle theorem. And the way this becomes helpful is when we have problems, we can talk about, even if we don't know the measure of the angle, we can talk about which angle is greater than another angle. Okay, let's practice it in the actual problem. So here we have in our first question, measures less than the measure of angle 7. So we want to know all the angles that are less than the measure of angle 7. Well, here's angle 7 right here. Okay, so we are looking for the remote interior angles. Okay, well, if I'm looking at the big triangle, here's one remote interior angle. So measure of angle 1. And then these two are the other remote interior angle. Okay, added together, they are the other remote interior angle. Which means that the measure of angle 7 is greater than both of those. So, added to our list, we have the measure of angle 2 and the measure of angle 4. Okay? But there's another triangle in this picture as well. Those three angles came from the big triangle. I'm going to change colors. We also have this smaller triangle. That 7 is also an exterior angle too. Okay? Now we already included 4 in our list, but the other exterior angle, or the other remote interior angle in this case, is angle 5. So the last one to our list is the measure of angle 5. Now with these, it's very important to locate which triangle you're talking about. So in the first problem, we talked about the big triangle. Alright, we talked about how 1 and then 2 plus 4 were the two remote interior angles. And then we looked at the other triangle, which was the blue triangle. So sometimes an angle will be an exterior angle to two separate triangles. We just got to keep in mind that's possible and look for all the possible options. All right, I'm going to erase, and let's do the next one. Okay. All right, now the next one asks, we want the measures that are greater than the measure of angle 6. So the measure of angle 6 is right here. Okay, so we're going backwards on this one. Instead of figuring out what measures are less than, we're looking now for measures that are greater than. In other words, we're wondering which angle is 6 the remote interior angle for? What are the exterior angles that 6 is remote interior for? So we've got this small triangle. Let's look at the small triangle first. All right, and 6 would be the remote interior of that angle, angle 3. 3 is the exterior angle to that red triangle. So we can go ahead and write the measure of angle 3. Okay, but just like the previous problem, there are two triangles floating around here, and we also have the big triangle, okay, that big blue triangle, in which case angle 8 is the exterior angle. And since the exterior angles are greater than the interior angles, or the remote interior angles, we know the measure of angle 8 is greater than angle 6. Okay, let's keep going. All right, your turn. So do number 1. The video is going to pause. When it plays again, you see the answer, and the same thing will happen for number 2. You go ahead and try to see if you can get the right answers first. All right, and here is the answer for number 1. So to show you, we have our big triangle right here. Okay, there's our big triangle, and the two remote interior angles for this would be 3 plus 4 and 5 plus 6. So those are the two remote interior angles for angle 1, so therefore they are less than angle 1. All right, keep going. Number 2. All right, and here's the answer. So for this one, angle 8's right here, and we want the measures that are greater than angle 8. So we look at our big triangle, and 8 is the remote interior angle to angle 2. Now, I do want to explain why there isn't anything else in this category. And the reason is that 8 is not a remote interior angle to anything else. Okay, we do have this small triangle right here. We do have a small triangle right here, but 8 isn't related to it in any way. Okay, there's no relationship over there to 8. So, therefore, since we don't know exactly how it relates, we can't say it's greater than 8. The only thing we know for sure is that 2 is greater because 2 is the exterior angle to angle 8. Now, what would a geometry video be without some theorems and other relationships? Now, the first theorem we have is the angle-side relationships. Okay, now this one states that the longer side of a triangle is across from the bigger angle. So in this picture right here, we have that xy is 9 and that yz is 7. Okay, well 9 is greater than 7. Therefore, the angle that 9 is across from, the angle that is across from xy, z, is the bigger of the two angles. Okay? So the bigger angle is across from the bigger side. And then the other theorem is just the reverse of that. Okay? The bigger side is across from the bigger angle. If in the bottom picture, J is greater than K, which that's what it says, then the side across from J, which would be, which would be KL, is going to be bigger than the side across from angle K, which would be JL. All right? And we kind of know this already. We've talked about it, or we've seen it a little bit, maybe, when it comes to right triangles. So if we think about it, if we have a right triangle, then I know that this angle right here is 90 degrees. And I know that the hypotenuse, this side right here, is the longest side of the right triangle. Okay, the hypotenuse is always the longest side of the right triangle, and it is across from the right angle, the biggest angle of the right triangle. Okay, so we've already kind of seen this. That means the hypotenuse will be greater than either of angle A or angle B, either of these two angles, because it's across from the biggest angle. Now the other one we got is the triangle inequality theorem. Now this one is referring to almost how do you create a triangle. Okay, so we talked about the angles of a triangle. Now we got to talk about the sides of a triangle. So the sum of the lengths of any two sides of a triangle must be greater than the length of the third side. Okay, they have to be, and we can illustrate this. If I have my third side right here, there it is, and I have two sides, and these two sides are less than my third side. Okay, they're my two sides. They are less than my third side. There's no way those two blue sides are ever going to touch and are ever going to create a triangle. Okay, they're just too short. Likewise, if I have my third side and my two blue sides are equal to, all right, then what's going to happen is they're going to fall short and they're just going to create this line on top of it. Okay, they're not going to create that top angle. They're just going to fall down and create a line. We don't have a triangle here. We have a line. So therefore, when you add the two sides together, it must be greater than the third. Okay, let's do some examples. Erase this. Example number 1. Is it possible to form a triangle with the given sides? Explain why not. If not, explain. So here we go. Is 8 plus 15 greater than 17? Well, yes, 8 plus 15 is. So therefore, this is a triangle. Okay, 23 is greater than 17. And you can keep cycling it. Is 15 plus 17 greater than 8? Yes, 32 is greater than 8. Ta-da! And last but not least, is 8 plus 17 greater than 15? Yes, 25 is greater than 15. Okay, so we just tried all three sides and it worked all three times. Now the shortcut way, the way to kind of cut down on this, is to test the two smallest sides. If the two smallest sides added together are greater than the third side, then it's kind of obvious the other two are going to work. And you guys do this next one. And here's our answer. We have 6 plus 8. Is that greater than 14? The answer is no. 14 is not greater than 14. 14 is equal to 14. And so in this instance, we would have an example where the lines, the sides, they would collapse and form a line on top of that third side. You wouldn't actually get a triangle. Now, since we have inequalities, what we're dealing with is a range of lengths, okay, a range of values. We're no longer talking about x being equal to a number. X is now greater than a number, or x is less than a number. And there's a lot. Let's just say we have x is greater than 6. There's a lot of numbers that are greater than 6. Okay? So this inequality brings in a range of values. So to answer this problem right here, if the measure of two sides of a triangle are 3 and 7 feet, what is the least possible whole number for the third side? So we want to figure out not only what's the smallest possible number that'll work, we also want to know what's the biggest possible number that'll work. Okay, because what we don't want is we don't want an instance where that's my third side, here's my second side, and then this is my third side. Okay, that's too big. Okay, so there's a perfect sweet spot of what this value is, and that's what we're going to find. So in order to find the greatest possible value, I'm going to add up my two sides. 3 plus 7 has to be greater than something, and that is 10. 10 is greater than x. So that's the biggest possible number the side can be. Now to find the other side, we're going to assume that 7 is our biggest side. Okay, so remember on the last side I said the shortcut is adding up your two smallest sides? Well, in this instance, in this first one we did, 10 is our greatest side. In this second one, we're going to assume that 7 is our greatest side. So I have x plus 3 is greater than 7. Okay, subtract 3 from both sides, and x is greater than 4. So now you have this range of values where 4 is less than x is less than 10. Any number in this range will make it a triangle. Okay, and so what's the least possible whole number that'll work? Well, the answer is 5. Because it can't be 4. That wouldn't work. That just gives us a straight line. 3 is too small, and 10's also wouldn't work. So 5's our only answer. All right, you guys do the next one, and when the video plays again, you'll see the answer. So here is the range of possible numbers. 4 is less than n is less than 22. Which means the value that cannot be n would be 22. It's the only one that doesn't fit in that value because n has to be less than. All right, you guys try. So you want to find the range of measures for the third side. So what this is asking you for is the full range. So the smallest is less than n is less than the greatest. Okay, try the first one out. When the video plays again, you'll see the answer. And here are the answers for both of them. Notice how both of them have the least to the greatest, and the least to the greatest. You have to have both ends. And with that, that is the end of this PowerPoint and the end of this video. Please, if you have any questions, make sure you write them down and let me know. Otherwise, I'll see you next class.